Okay, now we're getting into our actual equations, our balancing equations and everything. So hit pause and make sure you've copied down all the symbols we're going to be using, what they mean, and everything so that you know when you see them in reactions, in equations, you'll know what that means.
Alright, we got two types of equations. We have word equations and skeleton equations, and they mean exactly what the word says. Word equations, so they're made up of words. They have the names of the elements or compounds. So you see iron plus chlorine yields iron 3 chloride, all spelled out. And the next type is skeleton equations. We're just using the formulas, but it's not balanced yet. So for iron, we wrote down the formula for the symbol for iron, Fe. Chlorine, Cl2, and we'll talk about Cl2 in just 1 second. And iron 3 chloride. We wrote that symbol correctly, FeCl3. Alright, so why does chlorine have a little 2 after it? Well, it's special. It's one of the 7 diatomic elements. These elements, when they are by themselves, not paired up, are always found in pairs.
Sorry, I just left my book in here.
We have 2 ways to remember the 7. Brinkelhoff are the ones spelled out down there. We have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So you can remember the word Brinkelhoff, or you can remember 7 and 7. So you find nitrogen on your periodic table. Its atomic number is 7. Then you draw a 7. And then you can't forget hydrogen up there. So there's 2 ways to remember the 7 diatomic elements.
Okay, why do we balance equations? Well, everything is based on the law of conservation of mass, matter, and energy. I only say mass here, but we will talk about matter, energy, and everything in the next semester. We get to start playing with the heat and fire again. The mass that your products produce has to equal the mass of your reactants. Law of conservation is that matter is not created nor destroyed. Once you've written your skeleton equation correctly, using the information that we taught you in the last unit, then you balance the equation by changing the coefficients. So take a moment, pause me, or us I should say, and write down the steps, and then when we get to the next slide, we're going to do some practicing of that. Alright, so we've got some practice on the first one. So the first thing you're going to do is write the skeleton equation. So hydrogen is one of those special ones. So we write as H2. It goes with bromine, which is also special. And then we get hydrogen bromide, which is HBr, because they're both a 1 positive, 1 negative charge. So the next thing it tells you to do is count your atoms in your reactants. So sometimes you can put like a chart of what you have involved. And on the reactant side, you see you have 2 hydrogens and 2 bromines. On the product side, we have 1 of each. So we can see that if we add a coefficient, a whole number at the front, that will balance it out to each.
Our first one is carbon monoxide, so CO. Plus oxygen, which is one of those diatomic, O2, yields carbon dioxide, CO2. So if we make our little chart again, we count how many carbons and oxygens we have. On the reactant side, we have 1 carbon, and we have 3 oxygens. So you got to count both of those oxygens. And on the product side, we have 1 carbon, and we have 2 oxygens. So you can see here, our carbons are already balanced up, but our oxygens are not. Oh, yeah, apparently. Okay, so we're going to need some add a coefficient somewhere in here to balance them. Alright, so you can see the multiples there. You got 3 here and 2 here. So somehow we need to figure out what they have in common, what common multiple they have, so that we can figure out how to balance this. So, let's see. 2, 3. Okay. So if we add a, no, I'm trying to think of which one to add it to. So I need to add a 2, let's say 3.
Oh, wait.
Add a 2.
Actually, if we, sorry, we're arguing over, if we put a 2 here, that should give us 4. And, there, sorry, we were having a brain lapse. Whenever you have something in 2 locations, you do have to take into account everything. You're not necessarily going to be changing putting coefficients in front of everything. And then also notice that whatever you put in front of this, your product, your carbon dioxide, the only place where carbon was, you're going to have to put something in front of the other one.
And that 2 goes to everything. Goes 2 carbons, 2 oxygens. So now I have 2 carbons, 4 oxygens on that side. And then I have 2 oxygens, and then 2 more makes 4.
And that was a synthesis reaction. And you may consider it also as a possibly a combustion reaction, since oxygen was on the reactant side. And the first one that we did was also a synthesis reaction.
All right, last one. We have potassium chlorate. Make sure you're writing this formula correctly. It's going to break apart to form potassium chloride plus oxygen. Don't forget oxygen's diatomic. So if we make a little chart again so we can count how many we have. On the reactant side, we have 1 potassium, 1 chlorine, 3 oxygens. On the product side, we have 1 potassium, 1 chlorine, 2 oxygens. So somehow we're going to have to make these 3 oxygens and these 2 oxygens match up. The only way to do that is to make both of those guys 6. So we're going to add coefficients. So in front of, let's see over there, in front of potassium chlorate, we're going to have to add a 2, which changes potassium to 2, chlorine to 2, and oxygen to 6. Now we look at our product side. We're going to have to change it, put a 2 in front of the potassium chloride to make it a 2, and a 2. And then to make oxygen a 6, we add a 3. And sometimes this is just trial and error. You're just going to have to go through there and look and see if I've changed this. How does it change something? So don't get frustrated.
But going back to having your formula written correctly, if you've written it wrong, you will get into what I call a balancing nightmare, because you'll change one thing, and then that will be wrong, then you'll have to change something else, and then you just keep going around in circles and circles and never balancing. If you find that you're revisiting potassium on one side versus potassium on the other, you've written it wrong, stop, think of your charges, cross and drop, make it correct. Now, here's one, and you're going to get a lot of these, where it's going to say, using a whole paragraph, what we want to do. So you have to kind of identify what you have. You have sodium hydroxide and calcium bromide react to produce, so that's going to be where our arrow is, calcium hydroxide and sodium bromide. So we've gotten rid of all the other words that we're not paying attention to. So we're going to write sodium hydroxide, NaOH, and calcium bromide. That we have Br2 there because calcium is a 2+, and Br is a 1-, not because bromine is a diatomic. And we get calcium hydroxide and sodium bromide.
So now we're going to count how many atoms of each one we have. And as you must kill here has wrote OH as one thing. A little trick there is the polyatomic ions, if they're the same on both sides of the arrow, you can keep them together. It will be easier to count them as one thing. So if we look at the reactant side, sodium we have 1, OH 1, calcium we have 1, and bromine we have 2. On the product side we have 1 sodium.
Yep.
We have 2 hydroxides, 1 calcium, and 1 bromine. So you can see there, first we have the OHs don't match up and the bromines don't match up. So I usually just start somewhere. If my OHs don't match up, I need to add 2 more to the reactant side. So I add a 2 in the coefficient. But that changes the sodium and the OHs. So now I can look at the product side. I need to have 2 sodiums and 2 bromines. So if I add that 2, makes 2 sodiums, 2 bromines. So I can look at my chart, everything's balanced.